Hello. We're going to continue our discussion of decision trees. In particular, we're going to look at fine-tuning quite a few hyperparameters. So go ahead and open up a new Colab notebook and let's give it a new title. How about decision tree CLF? For this, our decision tree tuned, I think, would be enough. As I mentioned before, the classifier and regressor hyperparameters are pretty much the same. Okay, so I want to actually do it on a different data set. I want to use the heart disease data set. You can actually find the link via the hands-on gradient boosting with XGBoost and scikit-learn GitHub page, which is the optional text for this class. So if you looked it up on search engine and then click on it, you'll see we are still in chapter 2 here. And then here is the heart disease.csv file. So if you click there, and then whenever you're in a GitHub file, don't forget you need to view raw. Click on that. And then let's go ahead and copy that URL in and load it. All right. To do my URL, put it in quotes. Make sure I'm after the comma. And then recall that I want to import pandas as PD. df equals pd.read underscore CSV. This is the URL. And then let's look at the first 5 rows to see if it's what we expect. Or I should say what I expect here, since I have an idea of what it should be. Okay, so Google's taking a moment to load, and this looks good. You can see, so basically what we have here, these are rows of patients. And we've got different categories like the age, the sex, chest pain is CP. This is taken from the UCI machine learning repository where you can find more information on the individual columns. And target is whether they have a heart disease or not. Okay, so that's what we're trying to predict. Now, what we're going to do is just quickly build a decision tree classifier. Why classifier? Because the data is being classified all as zeros and ones. All right, so let's go ahead and do that right off the bat. So from sklearn.tree, import decision tree classifier. This beginning part will be a review from last time. And then let's go ahead and get like some of the other pieces in here that we're going to use. So from sklearn.model selection, import grid. I believe this is where grid search CV is. There it is, grid search CV. And what else are we going to use here? Those are key starters. I mean, if without the grid search, I guess we could do cross-file score, from SK. I think that's also from model selection. By the way, if it's from the same place, you can try a comma and then try cross-file score, and that's a cool way you can import 2 at once. Okay, I think that's sufficient just to start. What I'm doing here is just importing what I know for a fact we are going to use. Okay, so press Shift Enter. Now let's go ahead and split the data. So just standard way, x equals df.iloc. It's going to be all rows, all columns up until the last one. And y similarly will take just all rows and just the last column. Okay, so there I've got it split into an x and a y. And from here, we can build an initial machine learning model. Let's just use cross-file score to start with. So cross-file score. I want to put in the model first so I can put in decision tree classifier. And you can see, well, it was showing before. So now I'm inside the classifier, but when I was outside, see how it shows estimator like up here? That's basically the algorithm. And it shows you to do x comma y. Now don't do y equals none. We want to fit it to the y that we have. And the scoring here, the default is accuracy. But let's just put in some of the other parameters so that you know how to change them. Accuracy just means how many are correct. And then another nice one is CV, the number of folds. And let's just start with the default of 5. Okay, so this should give me 5 scores. And I can also get the mean of those scores. And, sometimes I write code in multiple lines, and you can also just do it all together, right? That's 5 scores. I can say, hey, I just want to get the mean of those scores, so I can do dot mean. Okay? So this is not a very big data set, so this should not take too long to run. Let's see what we get. 74% accuracy. Okay, so I'm going to say what we did here. Build decision tree classifier. Really, you're fitting it to the data. Score on 5 folds of data. Okay, so that is our starting place, and that is our starting score. Now, last time we looked at the potential adjustments if we change some of the parameters. So just to show you, if I just copy all of this, and then we'll use the grid search shortly, but note that I can actually change max depth here. And before, like, we had a max depth of 8 gave a better score than unlimited. So, this isn't the way to do it, but just note that you can just like try something and change the max depth. Recall that max depth is kind of the number of branches, the number of splits, the number of times the data is asking a question. So if I do like a 6 and I run it, I get slightly better. Okay. So if I have this data up here, like what it's doing and when it's splitting 6 times is it's saying something like this. Hey, if you've got we're going to split the data into 2 groups. If you have chest pain greater than 2 or chest pain less than 2, obviously 2 would have to go in one of those groups. And then that splits out into 2 groups. And if there was max depth of 1, we would stop there and then predict that the higher ones have a heart disease and the lower ones don't. But then maybe it splits again into male, female, or like certain age groups, right? And so basically it's splitting the data a maximum of 6 times using all of these different columns as possible options. And understanding that general idea of how the decision tree works is going to be, I would say, important to being able to get the gist of the hyperparameters. So the previous video goes into max depth quite a bit, so I don't want to go over that here. So what we're going to do next is look at some different, before I finish this one, let's just do it with the grid search, because that will give us the maximum max depth, and then we'll include other ones. Okay, so how can I do that? Well, I could call it my grid CV or something, equals grid search CV. And then I can put in my model. Do you see how it's showing see up here when you start doing it, like estimator, that's your decision tree classifier. Okay. And then we're not putting the max depth in there because we're going to search it with parameters. Now, so the params go here. Now, when I do that, I like to actually say like what they are up here separately, because it's just nice. And recall that it is a dictionary, not a list. Dictionary, and then you put in the name of the parameter followed by the possible options. So it could be none, no max depth, 1, the shortest one. I usually start with 2, 2, 3, 4, and then I start counting up by 2 so as not to go too crazy. And then this will then build, right? The grid search checks all of these options. And when you actually run it, it's going to build it, but it's checking all the options. And so you want to return the best scores. So if I try, let me just run it first. Oh, love it. Why do I love it? Got an error. So when I get the error, like it's here, it's clear. It says name params is not defined. Usually when you do that, it's a spelling error. So right, perms and params. Params is short for parameters. Try it again. This is also why it's good to run a little code before doing like tons of lines, because it's easier to troubleshoot your errors. But note that doesn't give me the scores. I've got to get them. And again, like maybe right here, I don't remember exactly how. So if I press the dot, okay, I can get the different options here. And you can see I get the score. I believe I want best params though too. I have that from memory. By the way, you don't have to scroll. You can just start typing. Like if it's like best, oh, maybe that's not what it's called. I thought that was what it was called. And then grid CV dot best, well, score. Okay. See, this is all from memory. And when I do it from memory, it only works so well. So look, when you're using code, okay, and you've already done it, you don't need to do it again. Go back to your previous notebook. Okay, so if I go back to colab.research.com, I see here's my decision tree classifier that I used before. Okay, so if I go back there and then I scroll toward the bottom part of it, I should be able to find when we use grid search CV, oh, right, separately we've got to fit it to the data. Okay, so I left out something pretty critical there, okay? And then it shows the best params and how to get the score. Hey, did I not? Maybe I didn't show the score last time. Interesting. So we'll have to look at that. So now if I go back, right, I see that there's clearly something missing. See, I initialized the model, but I didn't fit it to the data. See, with cross-file score, it actually fits it for you, and that is the difference, okay? So with grid CV, you've got to separately, note I didn't put in the X and the Y either, so it makes sense. Dot fit to, and you know, we could just, let's just use the full data set because it's going to do the cross folds for us. And so now if I run this, okay, it fits it. And does it show us here what the max depth is? Let's now try the best params first. And it gives a max depth of 3. Okay. And finally, well, is that right to get the score? See, now that it's been fit, we may have different options. Okay, so if I tried the dot here, yeah, do you see that? Best score. So now that it's been fit, it does show me like the best params option, and because it's different when it's been fit to the data. Okay. And so this now, when I show the best score, this is going to be the best score of the max depth of 3. And you can see it gives nearly 80%, which is better than the default of none, and also better than the 6, which I just picked as a kind of a middle guess.